Collecting a blood sample from a canine patient. So my restrainer is going to hold the dog still for me while I occlude the vein. We're going to try to use a jugular vein. Because I'm going to try to draw between 2 and 3 cc's of blood, I'm going to use a 3 cc syringe and a 22 gauge needle. You can hold your arm a little bit more towards you. I'm going to occlude the jugular vein and locate it on his neck. I'm going to clean the area with some alcohol before I draw. Next, I'm going to uncap my needle. And I'm going to stick. Oh, it's okay, baby. It's okay. Okay. We're going to try one more time. Good boy. Good boy. There we go. That's a good stick. That's a good boy. We're almost done. We're almost done. You're almost done. All done. If you can hold off for me. Oh, stay. Stay. That's a good boy. All done. That's a good boy.
You're embarrassing me.
All right. So we're going to remove our needle so we don't damage any of the red blood cells. We're going to fill up our purple top first. And we're going to rock that back and forth. Same thing with our serum separator tube. Okay. And then we're going to label our tubes next, and that is it. Perform the buccal mucosal bleeding time on this patient. So I have my lancet device here. I have the lip up here held by my gauze, and I'm going to use the lip surface here. As soon as I puncture, I'm going to start my stopwatch. I'm going to blot every five seconds. Until it stops bleeding. Normal is between 1 and 5 minutes for a dog. I'm not actually coming in contact with the surface that I punctured, so I'm just sucking up the excess blood here. A minute and a half. We're slowing down, but we're still bleeding a little bit. Almost done. Okay, so that's a minute and 57 seconds, and there's no fresh blood coming out of that puncture, so that is a normal test. I'm going to stop my timer. Okay, so to make my blood smear, I'm going to take my anticoagulated blood, and I'm going to take my microscope slides, and I'm going to take my well-mixed sample, and I'm going to dip my applicator tip in there. I'm going to place a drop of blood on the tip of, on the edge of the slide. Okay. And I'm going to take another microscope slide. And I have a feathered edge, which is what I want. You can see the frost or the feathered edge on this one. So this is a good blood smear. We're gonna take a look at this one under the microscope. Stain my blood smear, which has been drying, air drying. So I'm going to stain it in my 3 dip quick stains, starting with the fixer. Each one's going to stay in about 10 seconds. You can either move it in and out and dip it, or you can just let it sit in for about 10 seconds each. I'm going to just let it sit. I'm going to dip the excess off in between. Done with this, I'm going to rinse with some distilled water. Usually for all of our other slides we use tap water for most things, so I have some distilled water in here, just so that I don't get any debris or anything from the tap water to contaminate my slide. If it's dirty slides, things like fecals, it's not as big of a deal. I'm just going to gently rinse. Had an extra container like this, you could also use that. So this is going to air dry. Once this is dried, you're going to look at it under the microscope, starting at your 4x power, then moving your 10 and your 40 until you get to your oil immersion. And then I'm going to talk to you a little bit more about your process for looking at blood smears in another video. So that's staining a blood smear. I have it on my stage. I'm going to turn on my light. The first thing I want to do is get it into focus and find my monolayer. Okay. So I have it in focus on my low power. I'm going to continue to work my way up, keeping it in focus the entire way up. Each objective. Alright. Alright, now I'm going to add a drop of oil. Careful not to get it on any of my other objective lenses. So the things that I'm going to be looking for in my differential is, first I'm going to be trying to count 100 white blood cells, and I'm going to be distinguishing whether or not they are monocytes, lymphocytes, basophils, eosinophils, bands, and I'm going to count them so that I can get my absolute counts at the end of it. I'm going to be looking at red blood cell morphology, and I'm also going to be looking at platelets. I'm going to be looking to see if I see anything abnormal with my red blood cells, if my platelets look normal, and see if any of that lines up with my patient's symptoms and presentation for the day. So I just want to go over really fast a little bit about what you do actually break down for a manual differential. So the first thing you're going to do is take your PCV and total solids and get those numbers. Then you're going to take your PCV number, divide it by 6, and that's going to give you a red blood cell approximation, and that's going to be noted in millions per microliter. You're going to take your white blood cell number from your CBC, either in-house or send out to an outside lab. Then you're going to count 100 cells on your slide that you made, and you're going to notate all the white blood cells that you're seeing in that 100. That represents a total percentage out of 100 for each one of those. So if you have 50 lymphocytes in your 100 count, then that's going to represent 50% of your white blood cells on your CBC. So 50% on your 100 count represents an absolute number on your CBC machine, or your CBC count of white blood cells. So 50% of your white blood cell number would be lymphocytes in that situation. So that's how you get that percentage number if you're not looking at your CBC count to determine what your breakdown of white blood cells is. So that's why it's important to do the count and decide what type of white blood cells you're looking at on your slide. And that's why it's important to know what each white blood cell looks like. The next step is to look at your red blood cell morphology as you're scanning your microscope slide. Looking for things like target cells and Heinz bodies and anacytosis, I can't say that word, but anything that could be either artifactual or could be related to your patient's condition. You should always notate anything that does not look normal because it could be something related to your patient's medical condition, or it could just be handling error, but it's always important if it's not normal. So you want to notate that. And then one of the final steps is going to be also notating your platelet counts, or your estimated platelet counts. So you want to look at 10 fields throughout your slide, and you want to estimate platelets. So you want to count and give a range. So for example, looking at 10 fields, say 10 to 15 platelets per high power field. And that gives you an idea of where your platelet count falls compared to a normal value. And then when you're done, you would take a look at all of the values that you got throughout your differential, look at any of your abnormal values, abnormal cells, and then you would take that to your doctor. Okay, so now we are going to run a chemistry profile on a patient in-house. So the first thing that we have to do for this is bring our patient up and go into medical records. Now that we're in medical records, we're going to go actually to a different drop-down menu at the top, which is lab results. That is going to allow us to put in a request for our lab machines to run the test. So we're going to go over into this little drop-down menu on the right-hand side. We're going to put in a request. And now we're going to select our machine. In this case, it's going to be the VetScan 2, which is our chemistry analyzer, and select a prep profile. We're going to create our order, and then that's going to send it over to the machine here, which we're going to move the camera over. Make sure I have a good view here. Okay. So now that we're going to do this, we have our prep profile, which comes in these little rotors packaged individually. So you can use a couple different blood samples. So you can use a serum separator that's been spun down, or we have these little microgreen tubes that we can draw directly out of if we're doing like pre-anesthetic bloods or bloods right on the spot. In this case, we drew the bloods ahead of time and we held them until the owner wanted to run the bloods. So now that we get the permission after the fact, we're going to run the bloods now. So, I'm going to tear the label so I can actually see where the bloods are in here and where the serum is. What I need to do is open my rotor. And I need to get a pipette tip on here. A full depression on here gives you an exact draw amount for your rotor. So you want to make sure that you push down exactly and do a full draw. Okay, so I'm going to go directly down into my serum. Careful not to get into my serum separator material. It's a little harder to see because you don't have the red blood, but it's right up to that amount there. There is an arrow pointing to a hole in the rotor, and that's where you're going to insert your sample. And you want to be careful not to get any air bubbles. You're just going to introduce your entire sample amount. Once that's in there, you're going to analyze your bloods. Because we already put a request over and asked for much less information, but it's going to ask if it's a cat or a dog to confirm. In this case, it's a cat. And it's going to confirm the patient ID number. Okay, now it's going to analyze the sample. When it's done, I'll pick back up and I'll show you how to get those results from here over to the computer and import them. And then once we're done, we'll print them out. Okay, so our analysis is complete on the vet scan for the prep profile. So we're going to go over to our computer now. And we're going to go, instead of the lab request tab, we're going to go right next door to the lab reader. And we're going to find, which is actually highlighted because it's the last one we ran, we're going to find our prep profile for the correct patient. And we're going to select it. We're going to import it. When we go to do that, it's going to bring them up here. And it's going to give us a little preview here on the screen. And it's going to allow us to print them, which we're going to do. And then what that does is it also imports it into the medical record for this patient automatically. So it is already in the medical records as a line item. So when I go here, you can look, and this is our lab screen, and you see prep profile is already listed. So it's been imported and already there. So I'm going to go get that item off of the printer and put it into our paper medical record, and that is running a blood chemistry in-house. So today I'm going to show you how to run an ELISA SNAP test. We're going to use a 4DX test on a dog today that we ran, or that we pulled the blood on. So what we're going to do is we're either going to use a anticoagulated lavender top tube, or we're going to use a spun down serum separator tube. We're going to use the lavender tube today. We have our SNAP test, which comes in a complete kit, and that also includes the conjugate, which is the blue liquid here. So we need 4 drops of the blue liquid, and that's going to go in a single-use tube here, and it's going to be 4 drops. And then I'm going to open my test kit, and there's going to be a pipette in here. And I'm going to use that to get out my sample. And I'm going to use 3 drops of my blood sample. And that's after I've mixed my blood sample after inverting it 3 to 5 times. And I've got 3 drops of sample in here. Okay, so I'm just going to mix everything together just 3 to 5 times, just making sure that my conjugate and my blood sample have mixed together. So I'm going to put my sample into the well here, making sure I get as much of that in there as possible without wasting any of it. Now I'm going to wait for the blood sample mixture to get drawn up into my little sample well on the other end. It can take up to 60 seconds, and at that point is when I'm going to snap the test down. Once the test is snapped down, I wait for 8 minutes. I don't know if you can see that at all. If you can, it's just starting to enter. So I'm going to go ahead and snap down. And at that point is when I'm going to start my 8-minute timer. So it is now 12:29, almost 12:30. So 12:38 is when I'm going to read my test results. So I'll see you back in 8 minutes. Okay, so our 8 minutes is up and we have some results for the dog. So our test actually came back with 2 positive results, so I'm going to show you. So if we can zoom in on the test. So this upper left-hand corner is going to be our control dot. We always want to see a control dot come up on the test. That means that our test ran properly and that we have a successful test. If you don't see this dot, then the test is inconclusive and it's not a good test and you can't rely on the results. The other 2 dots that you see forming here are actually positive results for different diseases. So the bottom dot here in this little circle is positive for Lyme disease, and then the one higher up in the middle there is going to be positive for anaplasmosis, meaning that the doctor is going to talk to the owner about treatment options. So now we're going to read a PCV and a total solids. So to do that, we need a anticoagulated whole blood sample, which is in a lavender top tube, which we have collected from a patient. And what a PCV is telling us is the percentage of red blood cells in a whole blood sample. And it's also called a microhematocrit. Some doctors call it a microhematocrit, some doctors might call it a PCV in the hospital. And it's also part of a CBC, so if you run a CBC, you don't have to run a PCV, but you may need to run it in your hospital as a single separate test, so it's important to know how to do it. The things that we need are the blood sample and capillary tubes. And in our hospital, we tend to use the tubes with the red mark around the top, which means that they've been heparinized. And we like the micro mini tubes. Some hospitals use plain tubes, which usually have a blue ring around the top. We also have those, but we don't tend to use those tubes here, but we do have them in stock. You're going to need your clay. You're going to need your card to read the results afterwards. And then you're going to need your refractometer for your total solids, as well as your centrifuge. So what we're going to do is we're going to take 2 of our capillary tubes. It's important to take 2 because we need to have a balance so that we can run our centrifuge. And we're going to try to do them at the same time. That way we know that there's approximately the same amount of blood in both of the tubes. If the centrifuge is not balanced, it makes it difficult to run. It can throw the centrifuge off, and then you have to start all over. We're going to fill them until they are about 3/4 of the way full. Then we're going to stop and we're going to put clay in them, which is going to stop them up. And that is what is going to keep the sample from spinning out of the centrifuge. Okay. Alright, I don't know if you can see that, but there's clay in one side and the other side is not stopped up. Now we're going to put them in our centrifuge. Clay side always goes out. If you don't put the clay side out, the blood will spin out and you lose your sample and you have to start over. The time you spin it depends on the centrifuge you're using. Ours takes 5 minutes, so I will check back with you in a minute. Okay, so our PCV just finished spinning down. So we're going to open it up and we're going to have a look at it. To read the PCV, you need your card that usually comes with your tubes or your machine. And to read it, you're going to line up the bottom of your red blood cells to the 0 line and the top of your plasma to the top line or the 100 line. And you're going to read whatever line lines up with the top of the red blood cells is going to be your PCV percentage. So I'm going to see what that is right now. And I've always been taught to always double check. You do 2 tubes, so you always check both tubes. Make sure that they both read the same. And so for him, he is, I don't know if you can see this here, he's right at about 39. I don't know if you can see that with my glove behind it or not. So now, the next step before we complete this, a PCV isn't complete without a total solids reading. To do the total solids, you need a refractometer and you need your PCV tube. We're going to break the PCV right above the buffy coat layer so that we can get a couple drops of the plasma onto the refractometer. So we're going to carefully break the tube. This is always the hardest part. Okay. You want to make sure you don't get any glass pieces onto the refractometer. And you want to take it into a bright light source. .62, and the reading on that is always grams per deciliter. It's always important for you to remember to notate that in your records, or your doctor, or you, whoever's notating that in the records, to notate grams per deciliter, and then for your PCV to always notate your units for the PCV as percentage as well.